Black holes. They're amazing, but are they real or just science fiction? By following a series of logical steps, we're going to find the answer in under 3 minutes. Step 1. Observe and ask questions. Why does the Earth rotate around the Sun? Step 2. Research and construct a theory. Einstein's hypothesis, the general theory of relativity, suggested that planets rotate around the Sun due to curvature of spacetime. What is spacetime? It's like this fabric which gets distorted by mass causing orbit of planets. Step 2.5. Ask more questions. What happens when an object of infinite density, a large enough mass compressed into a very small volume, is present in this fabric? Black holes happen. When a star with a large enough mass reaches the end of its life cycle, it collapses on itself, leading to a point of infinite density, a black hole, which causes a huge distortion in space-time, leading to immense gravitational effects, so strong that even light can't escape if it passes a certain boundary, the event horizon. Outside this horizon are accretion disks, which is gas and matter moving around the black hole at near light speeds, heating up and glowing due to friction. And if you're lucky enough to enter a black hole without being torn apart, you'll find the singularity, which is the point of infinite density. But it's still all a theory, so we need to put it under a difficult test, trying to see it. Scientists used radio waves arriving from the accretion disks of a black hole in a galaxy called M87. These have a wavelength of about 1.3 millimeters. But in order to be able to resolve between 2 points in the sky that are 50 million light years away, you need to have a telescope with a diameter the size of Earth. How? By a clever trick called Very Long Baseline Interferometry. I like to think of it as a manual type of telescope. You'll get why in a second. A radio telescope works by automatically reflecting all waves that fall and focus it onto a point for processing. Now imagine that the Earth-sized telescope was a big basket, and the radio waves are water from this hose. The basket collects all the water that falls on it at once, whether water that falls near the corners or at the center. Now if I replace the basket with cups, it will collect less water, but basically it will collect water that falls in the same places. Rotate them and they will collect water from more places. Same if you add more cups. In a similar way, the Earth-sized telescope is replaced by a network of 8 different radio telescopes located around the globe, where the distance between them becomes the diameter of the Earth-sized telescope. This network is known as the Event Horizon Telescope. But since the Earth is curved, some waves reach a telescope before the other. That's why when you pour in and combine all the data, you need to synchronize them based on the very precise and accurate data of an atomic clock present at each telescope. After that, computer algorithms are used to complete the missing data, similar to a hangman game where your brain auto-completes the word for you when you get most of the letters. Only then can the Event Horizon Telescope team finally share the results, which is just pure magic. But what is even more magical is this series of logical steps, which converted science fiction into non-fiction, the scientific method.